Hi everyone, so in today's lesson we're going to jump into the PyGame library. We're going to talk a little bit about experimental design and creating an interactive task. This lesson will span over the next two lessons as well, so if there's something you don't quite understand from today's lesson, we may go a little deeper into it in the next lesson. So the first thing we're going to talk about is initializing PyGame, PyGame as a library like we talked about in the previous lesson. And we're going to set up a display window. We're going to show how we can render shapes, text, and images and display them on screen. We need to make sure that we manage this with a game loop and with timing so that we can display them exactly when we want to. And we're going to introduce a useful tool of game states so that we can manage the different parts of our task without having to have an over looping code. So to get started, first thing we need to do, I'm going to come over here and click the folder. If you're in VS Code, you can follow along for this. And I'm going to say lesson 03. Okay, .py and hit enter. And I'm going to split screen it out to the right so that we can follow along. Okay, so the first thing we need to do if we're going to use the PyGame library is import, just like we did with all of our other library packages. So we're going to do import PyGame, and if you notice, it has this little saying it's not access. That's because I do not have it installed in this virtual environment. So I'm going to come here and I can do conda install PyGame, and if you hit enter, then it will load through. Just give it just a minute, and as it does that, then you'll be able to access PyGame. So while that's installing, we're going to go ahead and finish typing out some of our code. Whenever we use PyGame, we need to tell the program that we're going to use PyGame. So the way that we do this is we initialize PyGame. We do pygame.init for initialize, and we'll put a little comment here. We're going to initialize a PyGame instance. All right, the next thing we need to do is we need to create a screen object. So a screen object is just anything that we're going to use to display our images. It's like a window or an application, anything that the user will be able to see. So I'm just going to call this screen. You could call it like my screen. This is a variable name, so you don't have to name it screen every single time, but for simplicity, usually I just name it screen. Okay, unless you're going to have multiple screens, then you have to name them something different. So we're going to say screen equals pygame.display.set mode. Now this command is one generic command that you're just going to copy and paste and you'll use every time. There is a full screen mode, but for this purposes, to make it easier for all displays, we're going to do 800 600. So this is going to be an 800 by 600 pixel window. So if you have a higher resolution screen, your window is going to look a little smaller than if you have a lower resolution screen, because this is raw pixels, not percentages of your full screen, which we could also use. So if you're curious about that, then let me know. It's also in documentation. Okay, and then next what we're going to do is we'll give it a title. So we'll say pygame.display.set caption, and I'll call this my first game, or you can say my cool game, or whatever you want it. This is going to be the title that goes at the top of the window. Okay, so now that we have that, let's go ahead and save. Looks like PyGame has installed. Let's see. All right, so it looks like the solving environment has failed. So we're going to try running it. It should still say that it has failed, and then I'm going to show you a little bit of how to troubleshoot that. Okay, so it still says no module named PyGame. So what we're going to do to try to resolve this, we could try typing it again, but more than likely it's going to fail. The best way to do it is go into your web browser and go up to the top and type in how to install PyGame conda. So when we type this in, one of the first things you'll see is this anaconda.org. This is a very good resource for anything that you're doing within the environment we set up for this course. So we'll click on that right here, and it will show you exactly what we need to type in in order to install PyGame. So if you notice, this has a conda forge. So occasionally there are some packages that require like this additional library in order to install it. So in this case, we're just going to copy that, come over here, and when we paste that, we should be able to hit enter, and we'll give it just a second. And then it is collecting metadata. Let's see if it can find that for us. And typically, whenever you're running into an issue with installing, it's probably because you have to install it with a slightly different name. There are some libraries that, even though the package is imported, for example, as PyGame or PyLink, sometimes you have to give it a much longer install name because there are multiple libraries that have that same name. Okay, so you should see this proceed, yes or no. So you'll type down here and type Y for yes, hit enter, and as you can see, it is installing this time. So we're installing the same code or the same library, and we're installing it with the same name, but occasionally it does require that difference in the way that we type it in order for it to properly install. Sometimes there is another installer that comes pre-installed with Python. It's usually not as successful as using Conda. So because we install Python using the Anaconda distribution, we can use the Conda install. There is a PIP install if you happen to see that whenever you're searching, and that is what we call pip install. That is the Python's installer package. Sometimes pip will work when Conda does not, but usually it's the other way around. If you are accustomed to using a pip installer instead of a Conda installer, using Conda works more often than pip installer. Okay, and now it looks like it has finished. So we're going to come over here and save, and as you can see, the little error underline has gone away, so more than likely it did install properly. And we're going to kind of come up here and we're going to click run, and you see it came up and then it closed immediately after because we're not doing anything with it, but it will say hello from the PyGame community. This means that PyGame was initialized, it started, but then our program closed because we were finished. So the next thing that we're going to do, now that we have an instance of PyGame, is we're going to create our task, our experimental design. So in order to do this, we want to keep everything within a while loop. Now, I did not introduce while loops in the logic lesson, and the reason is because while loops are very, very dangerous when it comes to crashing your entire game. So if you remember what a for loop was, where we could have like for x in range, and then it would just keep going until we got to the end of that range. A while loop is very similar, but it will continue going until you change some initial condition that you set to be true. So we're going to use a while loop because it is unfortunately the best way to keep your game running until you tell it to close. So in this task, we're going to say running equals true. Now, if you notice when I type in true, I did not put quotes around it because I don't want it to be the string true. I want it to be a different variable type named a Boolean. So a Boolean is either a 0 or a 1, or in most programming languages, you can use a true or a false in order to get that as well. So 0 would be the false and 1 would be true. We have to capitalize the letter T. When we do this, if I would have done it like this, you see how it gives me an error here, but when I capitalize it, or I could have done false as well, and then this tells you that it is of a type Boolean. Okay, so now what we're going to do is we're going to use our while loop, just like we would a for loop, while running, not ruling, running. Make sure you can spell. Okay, so while running. So while running is true or equal to a 1, then this loop is going to continue indefinitely until you force Control-C quit your program, or you change running to be false. So if I were to run this right now and I were to just say print something, and I'm not going to hit run, but if I did, then it would continuously run and run and run until I force quit Python, and it could crash your computer if it doesn't register the Control-C quit. So what we're going to always do, every time you have a running loop, you're going to want some kind of easy exit break loop in there. So the way we're going to do this is you can simply copy and paste this every time. We'll talk a little bit more about inputs in a little bit, but or in the next lesson actually. So for event in PyGame dot event dot get open close. Again, copy and paste. You don't have to change this up anytime. And this is basically just checking for any kind of event that's added to the log. So if you do something on the computer, it's going to send it to a giant log, and in that log that is going to need to be read by PyGame so that we know if there was a key press, if there was a button click, if there was somebody hit the X button on the program to try to quit it. We need to make sure that we're checking that log to listen for instructions. So for event, if event.type equals, remember we need that double equal sign when we're comparing in logic statements, pygame.quit all caps. So this is check and see if quit was pressed. Then we're going to do running equals false. Now I will tell you, we usually want to put multiple types of quits to get out of our running loop. In this case, I will use pygame.quit if for some reason you run it and it does not quit when you hit the X button on the window. You can click back out of it, come down here, and then hit your Control-C on your keyboard. Sometimes you have to spam it and hit it a whole bunch of times, and it will quit the game. Or you could go into your program manager, your task manager, and you can kill the application directly from there if it comes down to it. Okay, or kill your terminal shell by hitting this little kill delete button in the bottom. Okay, so now that we have this, we could run, and I'm going to save. And you can see we have my first game has popped up here, and then when I hit that X button, it closes like it should. If it does not close, again, you can just manually quit it. Some systems they handle the X a little tricky. Okay. So now the next thing that we're going to go into is what we call a screen flip. So a screen flip is similar to like the frames per second that you have on your computer. So if anybody's played video games before, you know you want at least like a 60 FPS, so you can't really notice that the screen is rendering over and over and you don't see anything like lagging and it looks more realistic. So it's a very similar idea. So as the game is running, your computer is recalculating this screen. So the screen that we set up here in line number 5 is just a virtual window that has not been displayed on an actual display yet. But in the computer, it has generated every single value of every single pixel within that 8x600 range that we have here. And as fast as the processor is able to run all of the code within this for loop that you have, this while loop that you have here, it's going to flip, and then it's going to flip, and then flip and over. But in order for it to do that, we have to tell it that we want it to update the screen. So if we just left it like this, anything that we display on screen would just stay there. And then if we put more text on top, it would just go right on top of the old text and then on top of the old text. So it's kind of like writing over and painting over what you had already written and never actually erasing what was there before. And we don't want this because this will slow the computer down, and it's also not very efficient because then you're going to get some things lagging and staying on screen that you don't want to be on screen. So at the end of each of these while loops, we always want to put a pygame.display.flip. All right, and then this is refresh the screen. Okay, so in general, you're going to have this. I'm going to put a comment right here. The real stuff. So this is kind of where your game goes between here and here. So the real stuff goes from here to here. Okay. So now we need to do one last thing. Once our while loop is at the end, so we have the quit, it's always a good idea to go ahead and tell the system that we want to quit PyGame. That way it's not a program that's running in the background. Sometimes it will lag, and when you start your task again, you will have another instance of PyGame. And then if you do this and you troubleshoot, let's say 100 times over the course of developing in one day, then you're going to have 100 instances of PyGame, and then it's going to progressively get slower and slower. So we're going to do pygame.quit. This way it will force the program to close in the background once we're done with it. Okay, so everything should look the same as it did before. We're going to run, we're going to have the screen show up, and we're going to hit the X button, and everything should close. This is the general overview of every PyGame you're going to have. So if you want to take this right here, you will copy and paste, you will change your name, you'll change the screen size, and then you're going to change the real stuff that goes inside. We're going to get a little bit more complex with that. We can add in some menus before we start the task, but in general, you now know how to create a game. So now let's get into, when you have a game, you have to show something on the screen, not just have that blank screen. So the way that we do that, and what it's called in PyGame, is a blit. So we can draw shapes, we can draw text, we can put images on the screen. There's a lot of different things that we can add on the screen. The shapes, we call them drawing instead of blitting, but we blit text and we blit images to the screen. So this is going to place whatever object you give it at a specific coordinate within this 800 by 600 frame that we created. So if I were to give it 0, 0, then it would be at the X and Y pixel coordinates, just like you would in geometry or in any math class. You're going to have your X and Y coordinates, and that's going to tell you where the top left corner of that object is going to be placed. So let's try, as an example, we're going to draw a red rectangle. I'm going to come here, see if I can copy and paste and make it a little easier. So once we have all the stuff, remember this is where the real stuff goes. We're going to paste this in here. Oh, got some spacing issues. So if you ever get an issue like this, where it's like, oh, well, there's something wrong, check and make sure you weren't supposed to have like your comment there, or you didn't accidentally add an additional space that you weren't supposed to add. So in this case, we are going to draw a rectangle on screen, and that rectangle is going to have your X and your Y. Okay, so we give it our X and our Y, and then the width and height that we want it to have. Once we're done with the width and height, so we have our X and our Y, width and height. This is the color that we're going to give. Let me add a comment here. So we're going to have past the screen object. So whatever we name the screen up here, you're going to do the same name here as that parameter. And then you're going to do the color fill that you want it to be. Now this color fill is in RGB. So if you're not familiar with RGB, you can go on Google and you can type in RGB converter, and you can get this cool little like color picker, and you could pick your favorite color, whatever color with like the GUI interface, and then it'll spit out your RGB color coordinates. So because we're doing it red, as you can see, we have 255, which is the max. These numbers range from 0 to 255. We're going to have 0 green component and 0 blue component. So it's going to be a pure red color that's displayed in every pixel between the size 50-50, starting at 100 pixels on our screen. So we're going to save, and we're just going to run before we do anything else. And now you can see we have this 50 by 50 grid, rectangle or square in this case, and it is placed at 100, 100. So if you remember, we have an 800 wide by 600 long, and this is 100 over and 100 down. The top left corner is placed exactly at these coordinates, and the color is this RGB color that we placed here. Now we can close the game out, and you have now created a game with an element on it. Now we can do the same thing by putting text on screen, but it's a little bit trickier for text because we have to create the text, then we have to display the text on screen. So I'm going to come down a little bit and we're going to tab these over. The first thing you need to do is you need to create what you want to write on that screen. So if you want to say, hi, how are you? Then you need to tell it you want, hi, how are you? Just as if you were in Microsoft Word and you're trying to type something out, you also have to tell it what font you want it to display in. So we're going to create a font element, and you do this only once for each game. You can create maybe multiple fonts. Let's say you want a font for headers and you want a smaller font, and this determines what font style you want and the font size. So if you use none for that font style, it's going to use the default font. So if you don't really care if you have a fancy font, I would typically say you want to switch between sans or serif. So sans having without those little brackets at the ends of all of the letters versus a serif has those brackets. A sans font commonly is like Arial, or you could have like the serif font, which is like Times New Roman, where it has the props. I don't know what you would call those. Sometimes a sans font is a little bit easier to read. So usually we just use a default sans or Arial. I'll type that in. There are some other ones that you can use. There's a couple of papers that will tell you which is easier to read for your specific task as well. Okay, so now we're going to render some text, and we're going to say, welcome to my first game. All right, so we put the text that we want to show on screen, and then we're going to actually show that text with a white text color. So because our background is black, we are going to use white so we can easily see it. And 255, 255, 255 means that we want all red, all blue, or green and all blue, which is the equivalent of white. Again, you can go to RGB color picker and get that. And if you wanted to change it so it was any other color, you would just change those numbers. Okay, and then this is where we're going to do screen.blit. So instead of pygame.draw, we're going to take our screen that we created and we're going to blit our image, or our text image in this case, on that screen. We give it the text object, and then we're going to tell it where we want it to put that on the screen. Let's save that and run it. And as you can see, welcome to my first game. All right, and you can see the pixels are a little off because we have a very low resolution, so we're getting a little bit of like pixelization in those letters. So you want to make sure your font's big enough that you don't get that pixelization and that it's not as bold. You can change your font size and you can change your font type if you're coming across issues like that. Okay, so now we put text on the screen and we have drawn an object. So the next thing we're going to do is we're going to load an image. So the first thing we need to do before we can load an image is we need to get an image. So if you have an image already on your computer, you can take any image you want. You just need to get the exact file name. So if it's a JPG versus a PNG or a JPEG, we need to know the exact name of that file. Otherwise, you can go online and you can download a sample image. Okay, so I actually have an image already. So we're going to come here. I'm going to copy all we have here, and we're going to, again, put it right here where all of the cool stuff for the game goes. Make sure you don't lose any closing parentheses. Okay, and my image is going to be called Sad Robot. Okay, and we're going to load the image, and this is going to be in the same folder that your current code is working in. If it is in a different folder, you could copy the entire path to that image, or you can just copy and paste it into the folder for the purposes, which is typically a better idea to have it all stored locally within the same folder so you don't accidentally move it later and then your images will no longer load and your game will not work because it will crash. It cannot find that image. Okay, so we're going to just load the image, and the way you do this is pygame.image.load. Give it the name of the image that you want to load, and then screen.blit, just like we did with the text, but this time we're going to pass it the image. That name can be whatever you want it to be. It is a variable, and we're going to put it at 300, 300. So remember our text was at 200, 300. Now we're going to do at 300, 300. So we're going to save it, and we're going to run. Okay, so if we see, it says no file sadrobot.jpg found in the current working directory. So this is where if you should always double check that your working directory, whatever is showing right here before you run your code, is the same as the folder that you're currently in. So if you're in Visual Studio Code, So if you notice, I'm in the teaching folder, coding bootcamp folder, and then lesson 3 folder, and that's where my current script is. Yet my working directory is only in the teaching folder. I have my image saved in this lesson 3. So there's 2 ways that we could fix this. We could come here and say, like, okay, well, I know I'm in this teaching folder, so I could write coding bootcamp slash lesson 03 backslash / if you're on Mac, it should work fine. I could do this and I could run and it would work. Or a little bit of a better practice is whenever you're running this code, go ahead and navigate to that directory within your terminal. So we're going to do coding bootcamp cd lesson _03. So now you can see my working directory is the same as where my actual file is. And we're going to run that again. And you can see it showed up here. Now, we do have a problem because my screen, the image that I'm loading, is larger than my screen. So if we don't want our image to be larger than the screen, when we load that image and we display that image, we need to specify what size we need to scale it down to. You will want to note that it can scale the image. So if you tell it you want it to be 50 by 50 and it's not a perfect square image, it will shrink the image and it will warp it so it won't maintain that image ratio. So take note of whatever the image ratio is and then scale it down proportionally. So let me show you how to do that. So if we come here where we loaded our image, we can say width, we'll be a little more descriptive with our variable names. Image, width, comma, image height equals image dot get. Okay, and what we can do is we can print image height and width. Okay, so for now, let's get rid of the blit just so we can see the image. Oh, okay. So whenever you go to run, if you're clicking the run button and it's not working, you're like, oh no, I've done it so many times. If you look down on your taskbar, make sure you don't currently have an instance of PyGame running. If you remember, we're still in that running while loop. It has not closed until we told it to hit this X button to quit the game. So if that comes up and it's not letting you run it again and you see this hello from PyGame without your current working directory at the bottom, then make sure to look for the PyGame because it is still open and make sure to close that. And then it will run it itself. And as you can see, it's running indefinitely. So I'm going to come up here and go ahead and quit that. And you can see the size of our image is a 500 by 778. So the way that we can rescale this is we can set a scaled version of our image. So we're going to say scaled image equals image. Oh, and make sure when we do this, we change this image that we're going to display on screen to scaled image. So as soon as you change that variable name, go ahead and change it in any future instances so you don't accidentally forget. And then we're going to be blitting the unscaled image. Okay, so in order to scale our image, the first thing that we need to do, we have that width and we have that height here. So we had the original image and we did get size, so that's returning our width and height. But we don't have our exact ratio yet. So the next thing we're going to do is we're going to do ratio equals image width divided by image height. So this is just giving us our proportion of width to height so we can compare to it later. And then we're going to say target, we'll do target height. So this is going to be our new scaled height is going to be our, let's say, target width. We'll set that equal to 150. So our target height is going to be our target width. We're just taking, this is arbitrary, we can set that to whatever size we want, and then we're going to multiply that by our aspect ratio to be able to get our target height, but In this case, we're going to divide it because we're doing the width and the height. So you can just copy and paste this when we named it ratio. Okay, so now we have our target height is going to have the same proportion as we just scaled down our target width. Okay, so whatever our target width was originally, we get a ratio of that. When we scale it down, we're also scaling down that height. Okay, so now that we're done with this, we could, if we know what our height's going to be, we could flip-flop that. But for now, we're just going to keep it like this, and then you would multiply. All right, so now with our scaled image, we're going to transform. So actually, let me erase this here. We're going to say PyGame dot transform dot scale. We're going to type image because that was our original image, comma, and then this is where we're putting our target width and our target height. And then close and close. Now when we blit that image to screen, instead of typing like this scaled image that we have here, we're now going to use, or instead of typing the image that we had before, we're going to use that scaled image. So our image has already been resized to be the smaller size. And we're going to get rid of this print statement so we don't have an infinite print within our while loop. Okay, when you're done with that, you can save and run. And as you can see, my image is now smaller. Because we did blit it at 300, 300, which is the same location as our text, we could lower this down, let's say 300, 400, and you can just kind of move it on screen. So if that's a little too low, we can change this back. We'll do 300 on the X coordinate and 350 for Y. And there we go. Awesome. Now remember that coordinate is where the top left corner of the image is going, where the top left corner of the text is going, or where the top left corner of the shape is going. But you are now able to create things and display them on screen. Congrats. So now we're going to get into something that's a little bit more complicated. And in this case, what we're going to do is we're going to create an organization for our task. So right now, all of the stuff we're doing, like drawing the rectangle, the text, and all of this, this is all happening within the raw code. But what if I only wanted to draw a red rectangle at the very beginning, or during the task, or when they finish the game? We need to have some kind of timing. And in order to do just a very basic sense of timing is we have this toggle that we can keep going back and changing the variable name to, and we're going to call that the state. So we can start in an instruction state, which is typically menu or instructions is the first state most people will start with. And then we move into the actual task, the experimental state. You could have multiple phases of this. So you could say task phase 1, phase 2, phase 3, or as many as you want, depending on your actual task structure. And then you're going to have like your game over or your finished state at the very end, right before you close out and go back to your main menu. So when we do this, we're able to execute. So instead of executing this code and drawing it on screen every single flip for the entire start to finish of the game until we hit the X button, we only show it on screen if we're in the state that we want to show it on screen. So let's do an example here. So I have a full code example here, everything except for the import statement. So we're going to take all of this. I'm going to comment out everything that we have here just so we can save that. And also you need your PyGame init in here. Oops. Okay. So we're going to come all the way to this and we're going to comment all of this out. Okay. So we'll come over here and we'll copy all of this down to here. And then I'll walk you guys through this little by little. And of course, I am not going to have any of my let's go. Everything here is going to be tabbed over because all of this stuff is within that while loop. Within this for loop, we have this if statement, and within this if statement, we have a running. So this is that check for quit we're going to have every single time we run the game so that we can close the game and it doesn't crash our computer. All right, so then we're going to create these individual different states. So I'm going to space these out a little bit here. We have, okay, so I'm going to put some extra spaces so we can easily see what's going on in our code. All right, so within this instruction state, we have all of this information here. And then within that task state, so if it's an instruction state, do the stuff inside of this chunk. However, if it's not in instruction state, we're going to go to the next state, which is task. If it's in the task state, do all of this code. And then if we're not in that one either, then do all of this code right here. Now you could also have an else statement at the very end and say like error, you're in a state that doesn't exist, but because we're writing the code, we're going to hope we don't do that. Okay, so now we're going to come up here and we're going to if in state instructions screen.fill. So we're going to create that plain background color, and then we're going to go text and then font.render. So we actually did have font up here before. So let's copy and paste that font. You do need to define your font each time. So we're going to define the font at the very top. We don't have to define it within our while loop. We just need to tell it what kind of font we're going to be using. Okay, so then we're going to have our screen blitting text. So we're going to say press spacebar to start. Now, for this lesson, you can copy and paste this 54 through 56 code. We will talk about that in the next lesson. But for now, just to get us out of states into the next state, we're going to have to accept a keyboard input. So if you copy and paste this, this is just saying if somebody hits the space bar, then go to the next state. State equals task instead of the instruction state. Okay, so what's going to happen is we're going to have this while loop. It's running and it's saying, okay, are we in instruction state? The first thing that happens is instruction state because we set it initially to be instructions. Then if somebody hits the space bar, so it's going to loop, 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 loop over and over. When somebody hits that space bar, we're changing the state to task so that it's going to skip all these again because that was already met. And then it's going to flip the screen, go back to the beginning, and then, oh, we're no longer in instruction state. So we're going to jump down to this because we changed it to task state. So we're going to, let's do a blue background for the task state. So we know that it has changed. And then you can put the rest of your task logic here, whatever you want. You can draw shapes, images. So we're just going to do that sad robot. What I'm going to do is I'm going to come all of this that I had up here. And I'm just going to paste it right here. All of this. And we can quickly uncomment that out. And we need to make sure that all of our tabs are aligned properly. So we're going to load that image. We're going to get the size. We're going to scale it. We're going to rescale the width and the height. And we're going to blit that image. Actually, I did not blit the image. We're going to come right here where we scaled it, and then we're going to display the image. Okay, and then again, just copy and paste this for now because we will talk about that in the next lesson. So we're going to just show that image on screen at this location until they hit the spacebar again. Once they hit that spacebar, we're going to go to the finish state, and it's going to finish this while loop, go back up to the top. Now we've changed our state variable. It's going to check. That one's going to fail because we're not in instructions anymore. It's going to check, it's going to fail, and then it's going to check and it's going to be correct because we just changed it to the finished state. And we're going to, we'll change it to a green background because it's finished. And we'll just say like game over, and then we'll blit that text to the screen at a specific location. And then we still have to hit that exit button in order to escape. Okay, so if we typed everything correctly, we should be able to run. We see the screen. It's always a good idea to click the screen before you start typing on the keyboard. We'll talk about that tomorrow or in the next lesson. Okay, so I'm going to hit the space bar. And if you notice, it's not doing anything. So what we need to do is I'm going to close this out, and we're going to go back and check something. And this is something that's very important. So if we look at our loop, So if we come up here, and I showed you in the previous one, we had this for, and all of this stuff is happening here. When we're down here, we need to make sure that all of our stuff is happening inside our game loop. So if we look at this for event in pygame.get, we're checking for events later to be able to enter that space key, but we're not inside that for loop anymore. We're to the left of the for loop. So all of our game logic needs to be tabbed over one time. And we can also come here and tab this over as well so that it is inside that for loop, and every time something happens, then we are refreshing that screen. So we're going to save it. This is where tabs are very important. It looks the same, but it is an invisible tab. And Visual Studio is very nice because it allows you to see these lines to see if it is lined up in the correct loop. So we're going to run. We're going to click on it and we're going to hit space. Yay, we are in task mode. So when I hit space, it flipped down here and went back up to our while loop. It started checking again, and we're no longer in instructions. Now we are currently in task mode, so it's filling the screen every time it flips. Then it is loading the image and displaying that image on screen every single loop. So it looks like it's a static image, but it's actually on there and constantly refreshing over and over again. Okay, so now if I hit spacebar again, try to think about what's going to happen before I hit the spacebar. So if we're here, if event is spacebar, I'm going to switch to the finished mode. So we're going to have, hopefully, the game over show up on screen, and we are done. We now have a simple task, and we are showing an image. We have some color. We have it separated by states, which makes it a little bit easier to maintain, and we can quickly say, okay, well, this is everything that happens when we're in the actual game. We could separate this out and put it in a separate function in a different script if you wanted to keep your code nice and concise. This is typically what you'll do if you have a very long game or task or experiment, but it's not necessary as long as you keep it all within that task mode chunk of code, then you will be good to go. So what we've learned here is we want to separate out our code into different states, and we need to make sure that all of our tabs are aligned, all of our images are scaled properly so they don't look funny. We need to make sure we display the images and the text and all that based on the top left corner of that image or text. So if you want it to be mid-screen, it's going to be a little trickier because you're going to have to calculate the width, and you're going to have to add the width of your image, and then you're going to have to divide and then subtract from the center of the screen. So it gets very complicated to do a center align, but it is possible. If you do left top align, then you don't really have to do much math. Okay, so the last thing that we're going to cover is a timing. So I'm not going to expect you guys to do this, but this is a very good idea when you're running a real task, is to set a clock for your task. So this comes in handy for two different things. So for one, you can control the speed of the game. So if you remember when we were running this and we had that print statement way up here before I commented it out, that print statement was just printing and printing and printing the width and the height of the image over and over every single time that the frame refreshes. That is an arbitrary refresh rate based on the speed of your computer. The refresh rate for what the image is shown on screen is either limited by the processor of your computer, how fast your computer can regenerate a new image, or it's how fast your screen can display it. So your computer may be able to generate 1,000 images in a second, but your screen may only be a 60 FPS, which is 60 frames per second. So it can only show 60 different changes of the pixels per second. Most of the time, refresh rate is not exactly what's marketed on that monitor. So if it says a 60 refresh rate, it sometimes could be higher than that. Sometimes it could be lower than that. But it also could vary based just on your computer. So if you have a much slower computer, then even though your monitor may be like a 240 hertz refresh rate, you may only be able to generate a 30 frames per second if you're displaying a lot of images and a lot of text and a lot of color and all of these pixels that have to be colored in. your computer may not be able to handle a refresh rate as high as your screen can display it. So in order to fix that, we can force the computer to have a maximum number of refresh rates. So then we don't go over the refresh rate that we know that our monitor cannot display, but it also reduces the load a little bit on the computer. So in those other heavier frames, then we're not clogging up our memory, and it can sometimes speed up our game a little bit and reduce the lag that you're going to have as you play the game. So the way we do this, I'm not going to put it into this code, I'm just going to explain it. We create a clock object at the very beginning before our while running loop. So we would go like right here, like on that line 42 there. And then inside your running, at the very top of your running, before you do that for event in the actual loop, we are going to set clock.tick and 60. You could set that to any number you want, but that's going to maximum limit to 60 frames per second. So this flip is not going to happen unless it's 1/60th of a second before it refreshes that, that running loop that you have here. You're going to leave all the rest of your code the same, and then you're going to have that PyGame flip. So all of this would be tabbed over because we have that PyGame loop here. But this is just something to always add. It is very good because then you can have like a start time and an end time. So if you're doing a task that is timing dependent, and let's say you want an image to display on screen for 5 seconds, then you're going to have to get the current time at the top of that refresh, and then you're going to have to calculate 5,000 milliseconds from that start time. And then if you pass that threshold of the current time, then you can turn the image off. And this is a very precise way of setting something to turn on or turn off at a specific time, regardless of user input. And if you set your limit to something that is reasonable, like 60 frames per second, then you're less likely for the computer to freeze up and then have some error in that timing, especially if you're doing a timing. If timing is very important to your task, you want to make sure you add this. Okay, so that's it for today's lesson, and I know it's a little content heavy, but in the next 2 lessons, we're just going to be expanding a little bit more on the PyGame and then how we interpret our data once we have collected it.